Hello, everyone, and welcome to this session on measuring uncertainty in resource modeling and why that's a good thing. Joining me today is Steve Sullivan, Technical Lead for Domain MCF at Maptek based in Adelaide. This year, we've had several webinars where we've explored applications of machine learning in mining and specifically how Maptek has applied this and other technologies in our Domain MCF service. Domain MCF has sparked great interest in the industry and has attracted many early access customers this year. If you've not seen those webinars, I encourage you to visit the Maptek website to take a look. Today's topic stems from concepts we have been exploring with customers who have been applying this new technology in their operations. This session focuses on geological uncertainty, and that's one of the topics that has often been overlooked because there has not yet been an easy way to capture or communicate uncertainty. However, it can be key to providing stakeholders such as mine planners and investors with a quantitative understanding of risk. At the end of the webinar today, we will have time for Q&A, so please enter any questions or comments you may have into the Q&A box in the meeting controls. You'll be able to do this at any time while the webcast is running, and we'll try to cover as many as we can at the end of the session. We are recording, so if you'd like to watch this again or to share it with colleagues, you will receive a link to access the webinar. So with that, we'll now pass it over to Steve.
Thanks very much, Jesse, for the introduction, and welcome viewers to what will be, I guess, an introduction and an exploration of geological uncertainty. So just as a bit of an introduction and recap, as resource geologists, we go through a large series of different data acquisition, processing and modeling phases to get us a resource model that we can state to whatever statutory requirements that we're obliged to do so. And listed a few of those on the screen there, and each and every one of those can have a level of uncertainty associated with that. So we might go to our analytical data, and there will always be a small window plus or minus of the value that is quoted in the spreadsheet that we might get back. So in today's session, we're just going to, we certainly can't cover all of that, we're just going to go look at domaining and interpretation uncertainty. And we're just going to explore that, have a general discussion, and certainly love to hear your input during the session so we can discuss that towards the end. But I'll set the scene and we'll have a look at a few concepts first. So initially, we're out to produce a tons and grade. We've got some type of ore body, some type of deposit, and we want to quote that to a resource standard, whether that be measured, indicator, or inferred. But we need to do that, and to do that, we have three components. We have a volume component. That's the spatial region that's covered by the material or the domain that we're going to report on. The density, so we can take a volume and multiply that by the density of the material and come up with a tonnage factor. And then we have a grade or a quality. So we have some type of attribute that we're attributing to that tonnage so that we can have that statement of tons and grade. So that's a well-researched, practiced process throughout the last 50 to 100, 200 years. So with respect to uncertainty, the grade or the quality, there's been a lot of work done over the last several decades. There's a lot of work that's done in simulations looking at and quantifying confidence levels in particular grades. So that's a well-established, well-researched area. Density, I guess over the last decade or so, I've seen density, the acquisition of density measurements, bulk density for samples increase in terms of the number and the quality of that. Going from years ago, people would take a few measurements, a handful, maybe up to 100 measurements, and then just assume across the entire rock type that is the average of those. But now I'm seeing tens of thousands of density samples being taken in some resource reports, which is really good. So they're looking at a rock type. It may be altered, it may be weathered, it has some modifying factors so that it has a range of different densities, and that's then estimated throughout the spatial volume. The volume, which I guess is defined by the domain boundaries, whether they be a wireframed or implicit model, or however you've generated your volumes. That is an area that I guess we're exploring today, which I see is hard work to generate in the first place. There's a lot of work involved in doing that, and often that work involves coming up with a unique answer. And a unique answer is the one that you've put all the effort into, and it's very hard to then come up with a counter interpretation and put the same effort to go through the whole process. Once you've built that, to do your variography and domaining and everything through grade estimation. So we're going to explore the volume and volume variations of different interpretations, that uncertainty that can exist within your volumes. So to set the scene, I set out a bit of a pre-webinar challenge, and thank you very much. We had a lot of contributions from you, the viewers. What I set here was just 5 simple drill holes with an interpretation of some type of material of interest in the red. And it's a 2D example and very simplistic. It's just to come up with an interpretation of that, but how you would join, how you would see that those individual intervals would join up. And there is no wrong answers to this, that all the answers are correct, and we'll review those answers in a couple of minutes. But why do we care about uncertainty? Why have got this topic in the first place? The reason is that, and I'm quoting here from an Australian example, our current JORC code, which is the code that really states how we should report to our stock exchange for resources. And as part of that, one of many parts of the table 1 there is that we need to report the confidence, or conversely, the uncertainty of the geological interpretation of the mineral deposit. So it's mandatory in our code, along with many, many other criteria that we're used to working with. If we go to the US, the SEC code from a couple of years ago, you can see there that they mention uncertainty several times throughout their rules for reporting. Cross over to the Canadian, the TSX, and again you can see the word confidence, which I guess is inverse to uncertainty. So again, that is a requirement. And in a more global context, the international reporting template of last year, again, mentioning the need to report the uncertainty estimates and discussed in the documentation in public reports. So, that is a requirement for all of our reporting. And this is just a general uncertainty terms, covering all the range of the different workflow that I started off on that first slide. So we did a little bit of research, and we had a look through some Australian examples over the last couple of years, some resource reports put out by large global companies, medium-sized companies and smaller companies, all putting resource reports, and how do they comply with that requirement to discuss the uncertainty. So just quoting from a couple, global confidence in the geological interpretation is considered to be good. So there's a mention of that. No quantification, no qualification, just that it's good. Again, some more words here. Confidence varies locally, depending on drill spacing, which is good. In this case here, mining in a particular district has been happening for the last couple of 100 years, and no alternative interpretations are considered viable based on the experience in that field. Then you have some people going a lot more comprehensively into that, a lot more detail. So I won't read that out, but you can read that. So they're looking at the grades, they're looking at the mineralization, they're looking at a whole range of different aspects, including the gold distribution. So, you know, and this particular one went on for a couple of pages. So they've gone, you know, very detailed into that uncertainty, which is really good. It makes sure that the investing public who's reading the report can go into that detail and get a good understanding that what's happening on a particular deposit. But out of the research that we did, the most common response was most company reports in Table 1 in Australia didn't mention uncertainty at all. They went on to detail about all the other aspects of geology, but the uncertainty was missing. So I guess that's something that as an industry we need to improve upon. Why do we do that? The reason we need to do that, apart from the statutory requirements, is that the geological uncertainty is something that has a significant impact on shareholders, potential and real. So we've got a couple of examples here on the ASX over the last couple of years. We've got a share price chart here with a quote, so the prices down on the right-hand side here. And in each case, up around here, there was a report of an updated resource with new tons and grades and all the appropriate information. At a certain period of time, many weeks or months later, there was a new announcement to the ASX. And in both cases here, it mentioned the problems with the geological model, in both cases an overestimate of the tonnage, the reduction in grade, and therefore the less material going to the mill. And you know, that's a big problem. You want to be able to prevent that type of thing happening. As geologists, that's not something that we really want to do. We want to be on top of these things. And in the case on this side here, the reduction in company value to the shareholders was about 140 million Australian dollars. So that is certainly something that I don't want on my head. So I think we all should take on board that there is uncertainty. The geology of a deposit never changes. It's our understanding and interpretation of the deposit that changes as we get more and more information. And we need to take that information and understand the ramifications of the decisions that we make so that we can prevent things like this happening. So that's the serious side of things. So let's have a little bit of, have a little bit of fun. Let's go and review your interpretation. So what you'll see is quite a few different interpretations of the challenge in an animation. So you get a couple of seconds of each, and then I'll summarize them and we'll discuss that at the end. So enjoy the viewing. So there we have it. There's your interpretations from that simple challenge. And I'm very, I guess, not amused, but just very surprised about the number of different answers that we had. You know, before I put the challenge out there, I came up with 2 or 3 and thought, yeah, that'll be it. And just the diversity of thought was I guess, in some respects confronting in terms of, wow, yes, but they're all correct. No one was wrong. They are all correct, and they could all be modelled into some type of geological context. And I guess, Jesse, I'll throw over to yourself now. As an engineer, and I know we're just looking at a 2D section, if this was to brought into 3D and you had to put a pit design around it, how would you feel as an engineer?
Yeah, I think the instinct would be to turn right back around to you and say, well, which one is it, Steve? Because we've become very accustomed to, here's an answer, now let's run with that, with the design and plan and schedule and so forth. So yeah, that would be my initial reaction. Well, which one is it?
And that's a fair call. So I guess, and as soon as we had one more piece of information, that would help rationalise the diversity of interpretations that we've got. And I guess that's something that as a geologist would say, okay, thanks, Jesse. You want one answer? Well, I'm going to go to you for some more monies for a drilling budget, and I'll go and drill a few holes and come up with a single answer for you. And I guess that was part of the second part of the challenge.
Yep.
So what I've done is I've ordered these your interpretations into an order, and I guess I've started with a sheeted, geologically, a sheeted vein system over here. And as we've progressed this way, we've kind of merging the interpretation and maybe coming across more of a, as we go this way, some type of more of a, maybe a stockwork or an IOCG breccia deposit style of thing. And coming over to here, we seem to have reversed the dip on here. Here we're dipping to this direction. Here we're dipping over here. We go to the second slide, we can continue that progression on and ultimately getting very creative. We're getting into some folded scenarios and then getting into some isoclinally folded and even some faults here. So a little quick analysis on this, and just reflecting, I thought that a lot of these different interpretations, and many of them which I didn't even predict, have come from people's past experience. You might have been working for a stratiform deposit that's been folded, and you come up with that interpretation on one of these varieties. Here we're looking at isoclinally folded material. So you might have come from, in South Australia, we've got the Challenger gold mine. That's exactly what it looked like, plunging deep at 45 degrees and M-shaped folds all the way down. Other people in the previous slide might have been working in a sheeted vein system or, some type of, as I said, breccia or complex. So whatever scenarios that you've worked in the past, that's kind of influencing your decisions. And that influence, I guess, is, we could put that down to geological bias. And that's not a bad thing. That's just your experience. And I guess the diversity of your team will help counter, the various different inputs and the different biases to come up with something that, I guess, a common thread for a deposit. So hence, teamwork is good. So where do we go from here? We've got, in this case, about 20 different interpretations of a simple single section. And they're equally geologically valid. There's no bad results there. There's nothing that looks like a star or something weird. They all potentially could fit into a geological model. And what do we use? As Jesse, the engineer, he wants a single model. What do we do for him? So we need to be able to quantify. We need to be able to reduce that to something that the engineer can work with. Now, as we mentioned before, great uncertainty. There's been a lot of work done on simulations, anything from 50, 100, 200, 1,000 realizations, and then giving a probability of a particular outcome. You could do a similar thing for the domain uncertainty. You could convert, in this case, we've only got two, ore and waste type scenario. You could convert that to a categorical indicator, and you could run a similar exercise. So you could put in this 2D example, you could put a grid of across that section. You could then put all the different scenarios into there and then quantify a numerical number or a heat map there for a probability or a confidence level of a particular block in that section being mineralized. And I've done that in a 3D case for a simplistic example. I built 3 different block models. I then added those block models together and then did some scripting and manipulation. And after a couple of hours of work and results, I was able to give a confidence level for that deposit. Now, that's okay for a very binary situation. Once you start getting multiple domains and multiple complexities there, that becomes a lot harder. So, we come to the point there that when we've got a lot of data, and in this particular case, we've got about 50 different domains, how do we do that? We certainly don't want to do that manually. Scripting will take some time to get the logic together and build that. So where do we go from here? So as Jesse mentioned, we've run a series of webinars and workshops this year on machine learning, application of machine learning to take some of the hard work of the geological data preparation away and allow you, the geologist, to spend more time thinking and analysing the data and coming up with solutions. Domain MCF is the Maptek product which defines those domain boundaries and provides now a measure of confidence in the placement of those boundaries so that you can then go through and have some level of uncertainty that you can then send through to engineering. How do you do that? Very simple. Down the bottom of the Domain MCF panel, underlined there in red, you just tick the box. Start the job just as you would normally do. It doesn't take any longer than the model would run without it, and then you get some level of indication. So we'll have a look at that with respect to the Lisheen mine in Ireland. The Lisheen mine is an underground lead zinc mine that finished mining about 5 years ago. Deposit's completely exploited now. The government of Ireland have put that data up on their webpage for anyone to use, so you can download up to about 100 gigabytes, and it's a really good data set for testing it and doing different scenarios. Talking to an ex-mine geologist there, traditionally it would take about a week to build a resource model. They had several different deposits in the same area, and a week for each one of those. Now, we showed in a previous webinar that Domain MCF could build the domains for that for a single deposit there in about 10 minutes. So we're reducing that and compressing that production of the resource dramatically there, giving you more time to think about it, rerun models, data validation, etc., etc. So using the same data, we've now gone through and done a block confidence on that. And here's a cross-section showing a cross-section through the block model. We've got some exploration drill holes here. We've got some production holes, short production holes underground here. And in the color scheme here, we have confidence, where green is high confidence and red is low confidence, using the old traffic light type signal. So you can see here, we have a couple of the zones of very high confidence within the mineralization. We've got repeated underground holes, we've got an exploration hole, and they're all coming up with the same rock type. So the drill holes are colored by rock type. Again here, now nice fan drilling underground. This is about 12 meters across this block. So you can see that good confidence, it's 90 plus on our scale. In amongst this is an area of lower confidence, and you can see here we're down to the yellow, we're down below 50% here. And that's been caused by, and a couple of the early exploration holes have been logged with a different code. Now you can see here's a repeat, but with an underground code, underground drill hole, and you can see that code is the same as all these ones. So this is a really good example of going back to your database, doing some data validation, checking the previous core logs, core photos, etc., just to determine if this is different generations of coding, these being the early exploration holes, and these are being the current, the more recent underground production holes. Are those codes the same? If they are, you can modify those codes, rerun the model, and in 10-15 minutes you've got an updated model, and hopefully there'll be higher confidence in that area. If not, then they are unique, then you can obviously come through and maybe model that as a separate lithology and treat that differently if you need to be. So there is an example of using the confidence as a data validation tool and going back and incrementally improving your results. Here's another cross-section and similar type color scheme where we've just got the exploration drilling. I haven't got the holes on there, but that's just the exploration drilling. And the same section, once we incorporate the underground production, you can see here we've got a lot more confidence coming in now. So, getting more data, improving the confidence by drilling. So if we go back to the previous one, you can see there's 50 to 90 on our scale, 50 to 70 on our scale. And once we've done more drilling, we're up to over 90. So again, the more data you've got, the more confidence you can have, you should have in your deposit. So on a quick wrap up, I guess we've explored that geological uncertainty exists. You contributed by doing that interpretation challenge, and I thank you for that. So it does exist, and we need to explore it. We need to make sure that we understand the uncertainty. We need to own that uncertainty. As geologists, this is our model. We are building a model that best reflects our understanding and knowledge of the deposit, so we need to own it. We need to learn how to share and communicate that with. So Jesse, the engineer, he needs to understand it. I'm not just giving him a model that says 10 million tonnes at X grade. I'm giving you a model that is 10 million tonnes plus or minus 5%, and I'm giving you a grade that's plus or minus 6%. And you've got to then communicate that, the importance of taking it. Could be 9 million tonnes or it could be 11. And here's the grades associated with that as well. Operate with confidence. A bit of a pun there, but we need to take that uncertainty and that confidence and build that through the whole process. As geologists, with the start of the process that goes through the optimization, planning and scheduling phase, and then it loops back again as we get more information. So we need to have the confidence to operate that. We need to generate resource security so that when we generate and release our model, that everyone knows and understands that that is what is in that model, and they take their assumptions as they build upon that into account. And we need to yearn to know more. This is just a very introductory webinar on one aspect of interpretation uncertainty. There are other aspects, and we need to delve into each of those and have a look at which one your deposit is most sensitive to, because it will be different in different deposits. And there's more information on our webpage about Domain MCF and the use of uncertainty. So the call to action, I guess the biggest challenge for myself and others is people's natural desire for certainty, natural desire to grab a single number and own that number, rather than look at a suite of numbers. We're not used to working with a best case, worst case scenario. So we need to be able to expand our mind and expand our range of thought and our communication skills to say there is risk in this, and here's what it is. So we want to hear from you now on how you manage geological uncertainty in your operations. I've done a lot of talking, and we'll break now for question and answers, Jesse, and see what the viewers think and consider from their operations. Thank you.
Thanks very much, Steve. That was great. As a reminder, if you've got any questions, comments, please enter those into the question and answer panel in the meeting controls. We'll take a look. We do have a few minutes for some questions, so we'll jump in and see if we've got any to discuss. First up, regarding machine learning techniques, it seems like an optimization problem. Is the machine learning technique used a reinforcement learning approach?
Yeah, I'll break that into two parts. The first part about being an optimization problem. Probably not in the true aspect of an optimization problem. We've got other branch within Maptek and evolution that deal with genetic algorithms and optimization, and that's really focused on that. It is more of actually the second part of that question, it's a reinforcement. It's a training and learning approach, so that the machine learning takes data, and as new data comes in, it is learning from that existing data and taking the new data and working together to apply the correlation in spatial 2D, spatial 3D, the correlation of that data and other attributes, because you can have grade attributes and geotechnical attributes and geomechanical attributes, taking that into account to come up with an answer, and then an uncertainty based on that answer.
Great, thank you. Let's see. What parameters were considered to quantify confidence, and were they weighed differently? How did you define the bins, and what did they mean? We've investigated the Sherman-Kent certainty classification, but open to other ideas.
Yes, the interpretation uncertainty is more than just the shapes that I've shown there. There are different components, and at the moment, Maptek's working on various components which will be released in coming months. So we started initially just looking at one, but we've got deeper work going to add more. because we've come up with a couple of other ideas. So the Shem and Kent is something that we haven't considered, so we'll have a look at that and report back at another time. And there was someone else who asked the question, Jesse, what units is confidence or uncertainty? And really it's just a scale. It's unitless. It doesn't have any SI units at all. So it's, in this case, it's just a scale, a relative scale.
Okay. Last question. Is this focused primarily on geological or volume uncertainty, or can it be similarly used for grade uncertainty?
At this stage within Domain MCF, it is a volume uncertainty that we're working at. We've got some work to do yet for grades and grade uncertainty, and that won't be delivered until next year. So, but this particular one is on volume uncertainty. There's certainly current techniques you can do with simulations, sequential Gaussian, indicator Gaussian, that you can do in conventional, Vulkan or other systems, which will give you that, shall we say, probability. I think they use that term, probability, for an outcome for grade. But yes, that is on our development pipeline, and we're released when it's ready and tested. So, and on that testing, we're certainly, we've got a lot of customers out there on the early access program, and getting a lot of good feedback. So if you are interested and you've got some data that you like working with, contact your local Maptek office, and we'll talk to you about that program.
Thanks, Steve. We're running pretty close to the end of time, so maybe just one quick question. With regards to the little challenge that you threw out earlier, you'd also asked us to consider adding an additional hole to get some better understanding of the geology. I saw there was a few that had been drawn in on the interpretations, but did you get other examples, and how did that one go?
Yeah, I did get some other examples, and largely it depended on the interpretation you made in the first place. So that, and if I think I'll just jump through a couple of slides here, we can just show you. So depending on where you are, you can see the different drill holes that were proposed depended on your interpretation. So over the whole gamut, I think we've had holes proposed between all of the existing holes.
We have a question here with regards to narrow vein deposits. This is something we've spoken about in previous webinars as well. Is there anything you can add to explain how we've explored narrow vein deposits in this type of technology?
Narrow vein deposits, I guess, are some of the hardest to evaluate. I've worked in structurally controlled shooting, plunging shoots, and they can be incredibly hard. And all you can do is more and more drilling. And I guess if we can provide an automatic way to show areas of uncertainty, that helps you to be able to justify to your management that you need more information in those areas. So I think as a justification for drilling tool, I think that uncertainty is a good measure.
Thanks, Steve. So we're right on time now. So I'll just finish this up. So for those of you that have participated in the Q&A section, thanks very much. For any questions that we didn't have time to answer now, we will respond to you directly. Of course, if you have any questions at any time, please send them through to us. We really hope you enjoyed the webinar today. As mentioned at the start of this session, we've done several webinars around this topic, as well as a host of other topics. So please check out the resources tab on our website to see some more webinars. Now, please take a few moments to respond to the survey, which is going to appear on your screen just now. This recording will be available this week, and you will receive a link automatically so you can watch it again on demand. And you can share that link with any colleagues within your organization. If you would like someone at Maptek to get in touch with you about anything that we've covered today, please contact us. You can see our email addresses on the screen, or your local Maptek representative will be available to help. So this is the end of our broadcast. Thank you very much again for your time, and please have a safe and enjoyable rest of your day.